Hello, geometry folks. This is Mr. Heeren. We're talking about 4.3. We're talking specifically about rectangles. Now, first and foremost, please realize that rectangles are parallelograms. So everything that was true about parallelograms is also going to be true about rectangles. So all that stuff, opposite sides congruent, opposite sides parallel, opposite angles parallel, consecutive angles supplementary, diagonals bisect. All that stuff is going to be true, but there's a couple other pieces that'll be true. First off, a rectangle is a parallelogram with 4 right angles. That is your dead giveaway. So we already mentioned this, I just did. Since a rectangle is parallelogram, opposite sides are both parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. A lot going on with rectangles here. So all of that is true. All this parallelogram stuff is true. Plus, there's 4 right angles in a rectangle. 4 right angles. So, in addition, in a rectangle, the diagonals are congruent. So, they bisect and they're congruent. So, kind of here's what that boils down to. That boils down to that the diagonals are congruent to each other. Well, if I said that this diagonal was 12 and this diagonal was 12, because they got to be congruent to each other, but I cut them both in half, that means every single piece is now 6. So that means every little corner here is going to be congruent. So what I also just created, or what happens when I do that, I created 4 isosceles triangles. Just something to think about. Here's the first one, second one, third one, fourth one. Just by doing that, you happen to create 4 isosceles triangles. So a rectangular park is 2 walking paths as shown. PS is 180 meters. PR is 200 meters. Find QT. Find that distance right there. Well, if it is a rectangular park, that means that is 180. And if this whole thing is 200 meters, I'm going to assume that this is the other diagonal. So if I cut these in half, that's going to be 100. That's going to be 100. This whole thing has to also be 200 because it's a rectangle and diagonals are congruent. So if this is 200, this has got to be 100 because diagonals are congruent. Because diagonals are congruent. So if TS is 120, where's TS? So TS, so right in the middle is there, that's 120. Find PR. So flipping that around, this is 120. The whole thing then has got to be 240. So that means this thing has also got to be 240. Same idea. So quadrilateral JKLM is a rectangle. KJL is 2x plus 4. So this whole thing is 2x plus 4. JLK is 7x plus 5. Oh, sorry, not the whole thing. KJL is 2x plus 4. JLK is 7x plus 5. How can I figure out what these are? Well, here's where you got to do a little thinking here. If I concentrate just on this this triangle, I know that it's right because the definition of a rectangle is it's got 4 right angles. I also know it has to add up to 180. So what I would like to do is realize that this is a triangle. Again, anytime you can use the fact that a triangle adds up to 180, do it because it's very easy. 2x plus 4 plus 7x plus 5, it's got to equal 90. Now you could write plus 90 equals 180, but then your first step is just subtract 90 over and you're done. So what I like to do is just realize, hey, these two got to add up to 90, so let's deal with that. 9x plus 9 equals 90. So 9x equals 81. X has got to equal 9. So realize that that's a triangle. Quadrilateral PQRS has vertices Negative 5, 3, 1, negative 1, negative 1, negative 4, negative 7, 0. Determine whether PQRS is a rectangle by using the distance formula. In a rectangle, opposite sides must be congruent, and diagonals must be also be congruent. So PQRS, we need sides, we need distance formula. Haha. X minus X squared plus Y minus Y squared. How can we figure out these distance? So if we look at PQ, we'll do different colors here. PQ, black. PQ is going to be negative 5 minus 1 squared plus 3 minus negative 1 squared. So that's going to be negative 6 squared is positive 36. 4 squared is 16. Put that together. I'll leave it as square root of 52 just so it doesn't get messy. So now, RS, we will look at in red. RS, negative 1 minus negative 7 squared. Negative 1 minus negative 7 plus negative 4 minus 0 squared. So this becomes negative 8 squared, that's 64. This becomes negative 4 squared, that's 16. So put those together, and what do you get? Square root of 80. Okay, halfway home. So next one. PS. So that's these two. So that's going to be negative 5 minus a negative 7 squared. 3 minus 0 squared. So negative 5 minus the negative 7 is really positive 2. Squared is 4. 3 minus 0 is 3. Interesting. So PS is going to be the square root of 13. Did I make a mistake somewhere? Ha, I did. This should not be, this one back here should not be 8. This one back here should be 6. So that should be the square root of 36 plus 16, which is also going to be the square root of 52. So that should be the square root of 52. My apologies, my mistake. All right, so last piece of the puzzle here is QR. QR, 1 minus negative 1 squared, negative 1 minus negative 4 squared. So that's going to be 2. This is going to be 3. So 2 squared and 3 squared, that's going to be 13. Okay, so we know that the opposite sides are congruent. All right, square root of 52, square root of 52, square root of 13, square root of 13. That doesn't mean that it's a rectangle necessarily. It could just be a parallelogram. All right, what we need to show now is that the diagonals are also going to be congruent. Sorry about that, announcements are announcements. All right, PR. Let's figure out the diagonal. So negative 5 minus negative 1 squared. 3 minus negative 4 squared. So negative 5 minus negative 1, or minus the negative 1 will be negative 4 squared, will be 16. 3 minus the negative 4 is going to be 7. That's going to be squared is 49. When I put that together, that's going to be square root of 65. So last piece of the puzzle here. QS. Let's see what we got. 1 minus negative 7. Negative 1 minus 0. 8 squared is going to be 64. Negative 1 squared is going to be 1. So this is going to be square root of 65. Yeah, that's my winner right there. Square root of 65, square root of 65. Absolutely, those two are going to be right. This whole thing is going to be a rectangle because those two are congruent. All right, using Pythagorean theorem, quadrilateral WXYZ is a rectangle. XW is 3. WZ is 4. XZ is C. Figure out what C is, figure out what WY is. So this whole thing, the diagonal is C. So, Pythagorean theorem time. oops, well, gave away the answer. 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. So square root of 25 is going to be 5. 9 to 16 add up to 25. So c is 5. So since it's a rectangle, wi must also be 5. That's all I got. Rectangles are pretty straightforward. Just got to remember everything about parallelogram is true. Plus, there are 4 right angles. And the diagonals are congruent. So everything parallelogram plus 4 right angles, diagonals congruent. All right, thank you for playing, and we will talk to you later.